Hello students, welcome back to my channel Learning Physics with Bhavya. Here I am having question paper, 2nd PUC midterm exam question paper of Bangalore South. Today I am going to solve numericals of this question paper. The first question is, two charges of plus or minus 0.5 microcoulomb are 10 to the power minus 9 meter apart. Calculate electric field intensity at a point 20 centimeter away from their midpoint on a line normal to the line joining the charges. And there is a condition, that is R is very much greater than A. So first let us consider two charges of 0.5 microcoulomb, that is one is plus 0.5 microcoulomb, another one is minus 0.5 microcoulomb. So these two are separated by a distance of 10 to the power minus 9 meter. So here we came to know that this is a dipole, right? Dipole. And the separation between the dipole is 10 to the power minus 9 meter. Now let us consider one midpoint. The line joining this, say the line passing through the midpoint is called as equatorial line, and let me consider the point somewhere here. Okay. So that point is called as R, which is at a distance. R is how much? 20 centimeter. This distance is R, which is 20 centimeter. And we can observe here that 2A is 10 to the power minus 9 meter. So A is half of this, which is very small, right? 10 to the power minus 9 meter is the smallest number, nanometer, 1 nanometer. So A is half nanometer, right? A is half nanometer. So that means here A is, the condition already it's mentioned, R is very much greater than A, right? So let us join this point to the charges. And we know that positive charge which produces electric field away from it, so this will be the direction of electric field due to positive. Negative charge which produces electric field towards it, this will be the direction of electric field due to negative charge at this point. And let us draw one parallelogram. So this will be the direction of resultant electric field. So dipole moment is acting from negative charge to positive charge. Dipole moment is always acting from negative to positive charge, and electric field is opposite to the direction of dipole moment. Now how to calculate electric field at a point P? So there is a formula to find out electric field at P due to dipole. So what is the formula? E is equal to constant K, P divided by R square plus X square to the power A square, R square plus A square to the power 3 by 2. Greater than A means R square is also greater than A square, very much greater than A square. Then A square term can be neglected. So therefore here R square to the power 3 by 2. So 2 cancel and you'll get R cube. So I'll directly write that formula, R cube. Okay, P by R cube. So first let us calculate P. P is Q into 2A. So Q is 10 to the 0.5, 0.5, micro is 10 to the power minus 6, into 2A is 10 to the power minus 9. So it is 0.5 into 10 to the power minus 10, minus 9 minus 6 is minus 15. So this is 5 into 10 to the power minus 16, right? P is 5 into 10 to the power minus 16 and unit is coulomb meter. Let us substitute that here to find out electric field. So therefore electric field is constant K is, what is a constant? 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into P is 5 into 10 to the power minus 16 divided by R. R is 20 centimeter. Let us convert to meter. That is 20 into 10 to the power minus 2 cubit. Okay. So 9 5s are 45 into 10 to the power minus 6 plus 9 is how much? minus 6 plus 9 is 7 minus 7 and 2 cube is 8 and here 10 to the power minus 1 cube is minus 3, right? So we can write 10 to the power minus 2 plus 1 is minus 1. Minus 1 cube is minus 1 into 3 is minus 3. When it comes to numerator, it becomes plus 3. So 45 by 8 becomes 5.625 into 10 to the power minus 4. So what is the electric field? We can also write electric field is 0.5625 into 10 to the power minus 3 Newton per coulomb. This is the answer. Newton per coulomb. Why it is Newton per coulomb? Because electric field can be written as force per unit charge. So which is Newton per coulomb. Right? And what is the direction of electric field at P? It is opposite to the direction of dipole moment. Okay? So this is the answer. Very simple. So just go through the condition applied. Since R is very much greater than A, we are using only this relation K P by R cube, and P we need to find out. P is not given. So which is one of the charges and separation between these two charges, that is 10 to the power minus 9. So we'll come to know that it is 0.5625 10 to the power minus 3 Newton per coulomb. Is it clear, student? Now the second question is from current electricity. As I mentioned in previous video, if the first question is from first two lesson, that is either from electric charges and fields or electrostatic potential and capacitance, the second question is always from current electricity. So in this paper you can see that the second question is from current electricity. So the question is very simple. A wire of length 2 meter, diameter 0.1 millimeter and resistivity which is given is connected in series with the battery of EMF 3 volt and internal resistance 1 ohm. Calculate resistance of the wire and current in the circuit. So we are having one wire. Usually wire is cylindrical in shape, right? So wire of length is 2 meter and its diameter is 0.1. So the diameter is given. Diameter is how much? 0.1 millimeter. Then how to calculate radius? It is diameter by 2. So 0.1 by 2 is 0.05 millimeter. So then what is area? Area is pi r square. Area is pi r square. That is 3.14 or 22 by 7 into r. R is 10 to the power minus 5 into 10 to the power minus 2 minus 3. So that is minus 5. 3.14 into 25 into 10 to the power minus 10. Okay. Now, so this is connected to battery and its EMF is given as 3 volt. EMF is 3 volt and internal resistance is given as 1 ohm. Internal resistance is also given. So we know that resistance of the wire is directly proportional to length and inversely proportional to area. If I remove this proportionality, there is a constant for this material. It is constant for the material, that is called as resistivity or specific resistance. Whatever be the size and shape of this wire, length and area, even if it changes, resistivity does not change. It is constant for given material. So this is a resistivity into L by EA. The value of all these are given. Substitute that, which is 1.963 into 10 to the power minus 8 ohm meter into length of the wire is 2 meter divided by area is 3.14 25 into 25 into 10 to the power minus 10. So if you calculate this number, you will come to know that it is 500.12 into 10 to the power minus 2. 500 divided by 100. See here 10 to the power minus 2 means it is 10 to the power minus 2, when it comes to numerator, it is 100. 500 by 100 is nearly equal to 5 ohm. So if you write this much is enough, no need of writing any decimal numbers. See, 5.0012 means it is nearly equal to 5 ohm. 5 ohm is enough. Now, we need to find out the current flowing through this wire. How to calculate current? So it is EMF divided by resistance of the wire plus internal resistance of the battery. Suppose if internal resistance is not given, then you can write only E by R. If internal resistance is mentioned, then substitute that here, okay? You add the total resistance. External resistance plus internal resistance. So therefore, current is equal to EMF of the cell is 3 volt divided by 5 plus 1, which is 3 by 6, that is 1 by 2. 1 by 2 is 0.5 ampere. 0.5 ampere. So this is very simple compared to the other questions, right? So R is rho L by A and I is E by R plus R. If you just give some focus on the concepts, then you can easily answer this type of questions, right? Sometimes students are writing this in wrong way, so please go through the expressions, write it properly. And while writing here, so you are making mistakes. R is D by 2, okay? So it is diameter by 2 is R, radius of the wire. And here it is millimeter. So you are doing some mistake when you are substituting all this. Please avoid this small mistakes, okay? So this is our answer for second question. So the third question is from AC chapter. Students, important. Please practice numericals of AC chapter, which is very important. Here there are two devices, that is resistor and capacitor. In LCR circuit there are 3, right? But only 2 are given, resistor and capacitor. The value of resistance as well as capacitance are mentioned. These two are connected in series to a AC supply, 220 volt 50 hertz AC supply. We need to find out current in the circuit and phase difference between current and voltage. So we are having one resistor and which is connected to capacitor. There is no inductor. This diagram is not needed. Resistance and capacitance are mentioned, okay? And this is AC supply, 220 volt 50 hertz. 220 volt and 50 hertz. Resistor is 200 ohm and capacitance is 15 microfarad. 50 micro is 10 to the power minus 6 farad. The question is to find current, RMS current, okay? Current means it is RMS current and you have to calculate phase difference between current and voltage. For that, first let us calculate to find out RMS current. We are using this relation. RMS current is Vrms by Z, where Z is square root of R square plus XC square. So since L is not there, inductor is not there, that's why directly let us use this relation. Where what is XC? XC is 1 over omega C, that is 1 by 2 pi F into C. Substitute 2 pi is 3.14, F is 50, C is 50, and the students, you are making the mistake here. Forget to substituting 10 to the power minus 6. Most of the time students are making this mistake. Okay. See, capacitance is always a very small number. It is even either in microfarad or nanofarad or picofarad. So there is a power, okay, 10 to the power minus 6, like this suffix will be there. So please see that, okay. So if you write just 15, it is meaningless. It should have some power, 10 to the power minus 9 or minus 6 or minus 12. So therefore, while writing, please write that is properly, okay, write that properly. And substituting, you will come to know that XC is equal to 212.3 ohm. XC is a capacitive reactance. Okay, it is same as resistance. It is a resistance or opposition offered by capacitor for the flow of AC current through it. So that's why it is ohm. Okay, its SI unit is ohm. After calculating XC, now let us calculate Z using the relation R square plus XC whole square. Substitute R value as well as XC value and square it, and you will come to know that, see, R square, if you square this R, it is 2 square is 4 and 00 square it is 40 plus XC is 212 square it, you will get 44944. Okay, adding and taking square root, Z is equal to 291.45 ohm. And one more common sense here is, see, if R is in 200, 3-digit number, XC is also 200 something, Z will be 200 something you will get, okay, 3-digit number. Now, RMS current is Vrms divided by Z. Substituting Vrms as 220 volt, Z is 291.45, and if you will get 0.7548 ampere. This is a RMS current. Okay. To calculate phi, phase difference between current and voltage, you can either use this relation cos phi is equal to R by Z. Okay. Or you can also use tan phi is equal to XL minus XC divided by R. Any one relation use. Now I'll use this relation, tan phi is equal to XL is not there, only XC divided by R. Or this can also be written as omega C and into R. Substitute and take reciprocal, you will get tan phi is equal to 1.06157. So in tangent table, you have to check the number. See, 1 is there in the second page. Tan 45 is 1. So after 45 degree, okay, you have to check in second page the number 0606157. So that means 4-digit number, that is 0615. Or near to that number you check, and you will come to know that it is nearly equal to 46 degree 43 minute. 46 degree 43 minute. So and in the row 46 degree you can see this number, not exactly, so approximate number you can see. So very close to this 4-digit number 0615. Okay, 12 is there. So the next column in number under the column 1, you add that, so to get this approximate number. So therefore the answer is phi is 46 degree 43 minute. Or you can also write 46.7 degree, 46.7 degree, like this. So students, you have to practice every day, okay. So practice number of questions, so that if you practice too many number of questions, then you can answer any type of questions, okay. So the questions are always like this only, to calculate phase difference, or to find out RMS current, or to find out capacitance, okay, or time lag between the current and voltage, like that. You practice so many number of questions, so that you will be you can able to solve any type of questions, okay. So in final exam, in preparatory or in final exam, you can expect this question is from either ray optics, wave optics, dual nature, atoms, nuclear. Okay. So here in midterm exam, the last question, that is 45th question, that is last one, is asked from ray optics. A double convex lens made of glass of refractive index 1.5 has radii of curvature 20 cm and 15 cm. which is immersed in water of refractive index 1.33. Calculate change in focal length of the lens. So here we are having one convex lens. Double convex lens means both the surfaces are convex. Okay, both the surfaces are convex. Convex means it is bulged outward. Okay, one is having radius R1, another having radius R2, and refractive index of this, let it be NG. Okay, so here what is given? NG is given as 1.5 and R1 is given as 20 centimeter, which is plus. Okay, R1 is positive because we are calculating along the direction of incident ray, and R2 is negative because we are measuring the distance between center of curvature to the pole in opposite to direction of incident ray. That's why R2 is negative, which is minus 15 centimeter. Right? Now, this lens is placed inside the water. When it is immersed in water, what happens to focal length? If I immersed it in water media, then what happens to focal length? First, let us calculate when it is placed in air medium. When convex lens is placed in, when lens is placed in air medium, how to write the equation? Focal length of glass lens, let us use this relation, n minus 1 into 1 by lens maker's formula R2. So using this lens maker's formula, let us write FG. G stands for glass lens. It is equal to refractive index of glass minus 1 into 1 by R1 minus 1 by R2. So FG we need to calculate. So NG is known for us, 1.5 minus 1 into 1 by R1 is 20. Keep as it is, no need of converting to meter. Okay, let it be in centimeter. Minus R2 is minus 15. Minus of minus becomes plus 15. So it is 1.5 minus 1 is 0.5. And here let us take LCM as 60. 20 3s are 50 4s are. So that is 0.5 can be written as half into 7 by 60 is 1 by FG. And if you calculate this 7 by 120, take reciprocal, FG is equal to 120 divided by 7, which will be 17.14 centimeter. Okay, no need of converting to meter because we need to find out change in focal length. So let it be in centimeter. Now let us place it in the water medium. When medium changes to water, see what happens to this focal length. See here, refractive index of air medium is 1. That's why I have not taken here, right? But when lens is placed in water, when lens is placed in water medium or any other medium, then what happens to focal length? It changes. Let it be FW. So here we are not writing refractive index as it is. We need to write refractive index of glass with respect to water, Ng by Nw. Okay, minus 1. Is this clear? How to write? Refractive index of glass with respect to air. Air is 1. That's why Ng by Na is Ng only, right? Ng by 1 will be Ng. So I have written as it is. Now, when medium changes, then here we need to write Ng by Nw into this remains same, 1 by R1 minus 1 by R2. So 1 by Fw is equal to Ng is 1.5, Nw is 1.33 minus 1, and this is same. Okay, so that is 7 by 60. Now 1.5 minus 1.33 divided by 1.33 into 7 by 60. So let us calculate. Here here we'll come to know that it is 0.0149, and FW take reciprocal of this number, which will be 67.11 centimeter. Then what is the change in focal length? So change in focal length delta F is FW minus FG. You are observing here that as you place convex lens in water medium, its focal length increases, right? Almost 4 times greater than that, right? So therefore, 17 fours are 68, right? So almost 4 times increases. It is one CET question. When you replace the air medium by water medium, or when convex lens is completely immersed in water medium, its focal length increases by 4 times. Okay. So FW minus FG, which is 67.11 minus 17.14, which is nearly equal to 49.97, or nearly it is 50 centimeter. 50 centimeter. Yes, go through it properly. I have written each steps neatly. Just go through it. And I solved all 4 questions in Bangalore South question paper, midterm exams. Okay. Students, the remaining questions here, MCQ and fill in the blanks, will be uploaded in my channel. Please go through that. 2 marks, 3 marks and 5 mark questions will be solved in next video. Thanks for watching.